Hi everyone, there is me Juice from Awesome Tuts, and in this video we'll create this cool 2D shoot the duck game. So when I unpause this game, I will shortly preview to you what we will make in this tutorial. So when I unpause this, we see that we have one simple again, and we have there ducks and targets that spawn to us from left and right side, and we can shoot them here in this scene. So you see ones go very fast, ones go slower, so on and so forth. So we'll create this cool game. So you see whenever we hit one of our some kind of enemies here, that enemy turn around actually, and he disappear, he gone out from the scene, like this one target here and like this duck right here. And we will create this game in this tutorial, so stay tuned for that, guys. Hi guys, Midjus here from Awesome Tuts one more time. And yeah, we'll start from scratch to create this Shoot the Duck 2D game in Unity. So you will see that I already have there a couple of folders. So actually I have here an animations, fonts, images, prefabs, resources, scenes. Okay, we have just one empty scene right here for now. Scripts and sounds. So all of these you'll get with the link in the description, but the main part here in this folder actually are our prefabs. So I actually made whole our scene into the convert that all our scene to the prefabs, and you later on, if you follow this tutorial, you can later on take these prefabs, drag and drop that right to the scene, and you are done with design of this scene. So then you just need to program all of that along with me in this tutorial, and you are done if you follow this tutorial. Okay, you see that I have there a circle target. Okay, this is our target actually that we need to hit or shoot whenever we play our game. And yeah, we will not import of course this currently in the scene, because this is going to be spawned along with our ducks in our game. But what we need to do here, or actually what we need to import here, is our crosshair, but we will import that later on. So first of all, we need to import our stall right here. So actually this is our appearance of our scene, this is our design, and this so I will shortly reset the transform right here, and when I go to the game we will see this. And yeah, I think this is very cool, guys. But I think that actually we need to position something here in front and something behind, so this is not snapped well here. So we need to go here into the stall and take our, so what is the curtains right here? Yeah, this is that. Yeah, this is the curtain, excuse me. So we need to actually position this in front of all of this, of all of these waters and grass and so on and so forth. So actually the curtains needs to be in front of all of this. So I will take our stall prefab, and I will shortly unpack this prefab. So I will go here, right click to the stall and click on the unpack prefab, in order to we can now change the elements of these prefabs, or child of these prefabs. And then I will take our curtains and simply and shortly choose all of these elements, or actually childs of these curtains. So I will choose all of them and simply change the order in layer from 5 to be now, for example, 10. And now we see that our curtains are now in front of our grass currently. Okay, then I will take our water. So where is our water? Right here. So I will try to find our water. So this is actually, yeah, this is the back wall, excuse me, front wall, back wall. And yeah, our water actually is here into the terrain. So we'll take our back water. So when I go here, this is the back water. We need to decrease of course this ordering layer to now be, for example, 10. Or yeah, we can decrease that to the 10. And also for the front water, also there will be 11, because this front water needs to be in front of this back water. But we actually made a mistake here for our curtains, so now we need one more time to take all of our curtains and actually more decrease this ordering layer for our curtains. So when I go to the game, yeah, we will see this. And yeah, guys, I'm satisfied so far with this appearance. So now we set up our stall right here that we have imported. Now we need to import also our gun right here to the scene. So I will import our gun, and of course, so our gun is behind of all of our here stalls and so on and so forth, elements from the stalls. So we will of course remove these missing scripts from our gun, and yeah, instead of adding a component we need to take our gun right here, take this graphic of our gun, and of course pump up this ordering layer until, yeah, so now on the 100, so we can, I think, pump up that to the 15, and we will see our gun graphics right here. So yeah, this is that, guys. So when I go to the game, so we'll see in that way our gun, but when I go in the scene one more time, so we will definitely a little bit move down this gun right here, so you can just copy from me this position on the XY, and then you can position this on your own. Okay, this will be the position for our gun. So we also imported our gun. We see that our gun currently just have this graphics in it that is actually a sprite renderer, and that is that, guys, about our gun. So also we forgot one thing in this stall, and that is when we go here into the back wall, or actually I think we need to go here into the front wall. We also need to pump up the ordering layer for this front wall in order to actually our gun be we need actually to make the appearance that our gun is some kind of standing in this front wall that I currently have here, that I clicked here, and we need to actually have that appearance right here. So I will one more time take our gun, or actually the graphics of our gun, and make that, if I can do that. Yeah, this is that appearance that I wanted to make here, that we actually show in the preview of the game. So this is going to be that appearance, and guys, I think this is that for our appearance. So I think that the last thing that we need to import here is our crosshair, or actually our scout, or call it however you want. So this is the crosshair of our gun. This is going to be the representative of our mouse button movement, or our mouse movement, excuse me. And yeah, this is that for our scene, guys, for our design of our scene. Now we need to program, first of all, movement of this water, then movement of our gun, and movement of our crosshair for the first part of this tutorial. So this will be that 3 movements in the first part of this tutorial. Then on the second part we will make a spawner that will spawn to us our targets and the ducks, and you will see that later on when we going to create that. Okay, I will go here in the scripts folder that I have created, and I will simply and shortly create a new C# script which is going to be for our water movement. So I will simply pass here name water movement, and you can imagine this will be attached on our front and back waters, and we will make actually that this water we will make some kind of movement that this water will have. So this is not going to be some animation, this is going to be simply repeatable code that will be executed every frame, and you will see that in a second when we open this in our Visual Studio. And once we are in our script, we will have in this script just one variable, and that variable will be public and then float, and then we will call that variable speed. So that's going to be actually the speed of our water movement, and this is going to be 0.5, so 0.5 f by default. So we give actually the default value to this variable, and then we are going to delete this start method. So this is going to be the shortest script, believe me, in this tutorial. So we will have just that one line of code here in the update method, and that is actually our transform.position. So we are going to store that into the new vector tree. So new vector tree, open the parentheses, and for the first argument, that is for the x-axis, we are going to use one function, and that function is actually a mathf.cosine. So when we import here, this is the library for our mathematical functions. So this mathf is the library for our mathematical methods and functions, and we are going to use a cosine for our x-axis. So we see that we need actually to provide a float f for our cosine. So we see that this returns the cosine of angle f that we need to import, that we need to pass here into the parentheses. That then we need to import actually or pass here time.time, which is the real time. So when we point with our mouse here, the interface to get time information from Unity, and this time is actually the time at the beginning of this frame. This is the time in seconds since the start of the game. So this is the real time since we start the game. So this is going to be for the x axis, but for the y axis we need to pass similar method. So now we need to pass here again mathf, but this time it will be sine. So in the sine we also need to provide a float f that is going to be returned, the sine of angle f that is going to be returned. So actually we also see that one shorthand that this f is actually the input angle in radians. Yeah, this is some pure mathematics and physics. If you want to know more about these actually functions from the mathf library, you need to go in the Unity documentation, as I always suggest to you much more about these functions that you are interested in. Okay, and also for the mathf sign we need to provide a time.time. Since our game is started, we need also to provide this time.time. So actually the vector chi, vector chi are actually the representative of our current position of our water, will be stored in the cosine for the x-axis and in the sine for the y-axis, and then our sine or our x-axis and y-axis will always be updated because we actually control that cosine and the sine via the times. So we will always calculate our time whenever we start our game. Just when we turn off the game, we will actually quit the time, so we will exit that time, and then also this function will stop to work. Okay, then we need to multiply this with the speed. So actually we will just multiply this y-axis with this speed variable that we have created, and you will see later why. And then we can now easily save this and go back to our Unity. And of course, before every testing, we need to attach this water movement script on our back and our front waters, so that is our game objects from the stall. So when we go here, yeah, we see here a back water and actually a front water. So we will take these two game objects. So we are of course going to remove these missing scripts and attach our script. So we are going here in the add component and search for our water movement that have this speed variable. And now I'm pretty sure that we can test this behavior out. So I will go here and simply play our game. And now guys, we see that our water some kind of dancing right here. So yeah, this is effect that we wanted to create for our water. Our water is moving and we achieve effect that we want to create here. So now moving on, we also need to create a movement for our crosshair and our gun. So we are going here to create a new C# script which is going to be a gun movement. So there we will actually program that behavior and simply open it up in our Visual Studio like our previous script. So in this script we will have our three variables. First one is sprite renderer. So we need to search for there is our sprite renderer, and then for this we are simply going to call that variable sprite renderer like this. So render, for example, just a render, and then we are going to store that this is going to be by default on the null because we will not always have this sprite renderer. Okay, then we are going to take the reference from our camera. So we are simply going to pass here camera and then call that variable simply cam right here, for example like this. And also we are going to store that by default this is going to be equal to null. Then we are going to create the last variable that is going to be a public float and then offset like this, and then we are going to provide the default value for this variable that is going to be 1.5f, so in the floats. And then in the start method we are immediately going to take the reference for our main camera in this variable, so that's our cam variable, and we are going to pass camera.main and store this variable to this camera.main, and now we can manipulate with our main camera with this variable right here that we have created. Okay, then in the update method we are going to use our vector2. So vector2, and then we are going to create actually a variable that is going to be for our mouse position. And then we are going to take our camera and then say right here that we want screen toward point, so that is actually screen to, and yeah, I made a mistake here, there's no camera, there is actually our variable that represent our camera, and then we need to pass here screen to world point, and then we are going to open the parentheses, and in the parentheses input dot mouse position, in order to in this variable mouse position we take our actual mouse position, so input dot mouse position. And now moving on, we are going to create new boolean variable which is going to be a flip. So in this variable we are going to pass our mouse position on the x-axis, so mouse position dot x, and then this is going to be less than 0. So what this means, so actually this flip variable, boolean variable, will be true if our mouse position on the x-axis is less than 0. So is actually less than 0. So that will be our boolean flip variable. Then we are going to take our sprite renderer that we have created, and then we are going to say here a flip on the x-axis, and then we are going to simply store that to our flip boolean variable that we have provided right here and that we have checked right here in the continuation. So what we have done right here, so actually we take our sprite renderer and then flip that renderer on the x-axis. So actually the sprite renderer is the render for this gun movement. So this is actually the graphics of our gun, and then we flip that graphics on the x-axis. So when we will flip our gun, we are going to flip our gun if this flip variable here is true. So if this boolean flip variable is true, and I explain when this flip variable will be true previously. Then last piece of code here in this update method is actually transform.position. So now we are going to take our current position of our gun and then store that to the new vector tree. So this time there will be vector tree, and again for the x position we are going to take our mathf library and then create a new function that is clamping. So we see that actually this function clamps the given value between the given minimum float and the maximum float. So I made a mistake, so there is and maximum float values, returns the given value if it is within the minimum and max range. So then we are going to open the parentheses, and we see that this takes 3 arguments: float value and then minimum and maximum in floats again. So we are going to take our mouse position, this is going to be our float, so on the x-axis of course, and then we are going to add on this, so we are going to add and open one more time these parentheses, we are going to pass our flip, and then we need to pass a question mark and then minus offset that we have created in the variables, that is that variable, and then we are going to pass here 2 dots and then again offset, and then we are going to add a comma here, and for the second parameter here in this clamp function we are going to add here minus 8.5f, and then we are going to add one more time comma, and for the maximum float we are going to pass 8.5, so simple 8.5. so actually these two last arguments are minimum and maximum floats, and this first argument is actually our float value. Okay, then for the y-axis we are going out of these parentheses, and then for the y-axis we are going to simply pass transform.position.y. So this is going to be for the y-axis. And what we did here, so we take our current position of our gun and store that into the vector tree. And for the vector tree, we know that this takes 3 arguments, so for the x, y, and z. And for the x-axis, so this that I marked here is for our x-axis. So this is actually mathf clamp, and then for the, we take our mouse position on the x-axis and add that into our expression, into our boolean expression. And what here is expression? So there is a so their boolean expression is this flip. So this is this variable that will be true if our mouse position on the x-axis is less than 0. So this will be true, and actually what does this question mark mean? So I explained that in previous tutorial, I think. So this means that if this flip variable is true, then this minus offset will be true. But if this flip variable is false, then this offset will be false in the positive. So not minus offset, but just the offset in the positive plus offset will be false if this is true. But if this flip is false, then this minus offset will be false, and then this offset will be true. Then this positive offset then will be true. So that means this question mark, if we add a question mark in the boolean expression. Then for the minimum x and maximum x we pass here minus 8.5 and 8.5, and therefore for the y-axis, we didn't touch our y-axis, we pass simply transform.position.y, and that is that for our gun movement script. I hope you understand everything right here. I saved that script, and now we can easily go back to our Unity editor. And of course, like in the previous case, we are going to attach this gun movement script on our gun right here. So we are simply going to drag and drop that into our gun. And for the sprite renderer, we need to take our graphics of our gun and simply drag and drop that into this empty slot right here. And we fill up everything that we needed to do here. Okay guys, now we are ready for new testing right here. So we are going to test our gun movement and we are simply going to play our game. So guys, you see that we can now move our gun right here into this bounce. So actually to this bounce, so then we cannot move more than this into the right side and more than this into the left side. But I think we need to decrease a little bit this x positive value right here. So we need to decrease that definitely, because in the left side we cannot go more than this. But anyway, we achieve a fact that we wanted to achieve here. So now you see that we actually flip here our x sprite renderer when we go more than 0. So now we are going more than 0, and you notice that we flip actually our render of our gun, and then when we go less than 0, we again flip this. So we again flip our gun on the x-axis, we flip that sprite that we have coded, and guys, we make a behavior that we wanted to make here from the first try, and yeah, I congratulate you on that. Okay guys, that was that for our gun movement. Now we are going back to our scripts and then creating a new C# script, which is going to be for our crosshair. So we are going to simply pass here crosshair and then movement, and again open it up, of course, in our Visual Studio. And in this script we will have just one variable, and that variable will be private camera. So again, we are taking the reference for our main camera, and then we are going to again actually say that this camera is equal to null. Then in the start method, we are going to just exactly like in the previous case, take the reference from our main camera, pass here camera.main, so just like we did in previous script. And then in the update method, again we are going, so actually we can go here into the gun movement and simply take this code from the update method. So I am going to copy and paste this right to this new script right here, and now we are going to change some things right here. So actually for the mouse position, we are going to say the exactly same thing. So we are going to say that this mouse position is equal to this input.mousePosition, real mouse position. Then we are going to delete this boolean flip variable because we don't need this in this case, and also this sprite render, we need to delete that. Then we are going to actually create here a new line of code that is going to be for our cursor. So we are going to take our cursor.visible. So actually this will detect if our cursor is visible or not. And then we are going to store that. So mouse position into the x-axis, we are going to check if our mouse position is less than -8.5. So we are going to pass here -8.5 f. Or, so we are going to use our or operators. Mouse position again on the x-axis, yeah, is greater than 8.5, but this time into the positive values. We are going to pass that expression, so again f here, and then we are going to again pass our or operators, or mouse position on the y-axis. So now we are changing the axis, so now we are checking for our mouse position on the y-axis. If our mouse position on the y-axis is less than of -3.5, so I need to pass here -3.5, then we will do the next. So then we are going to again pass our operators, so again my mouse position into the y-axis is greater than, but this time into the positive values, 4.5f, like this, and then semicolon. And what we have done here, so actually we take our cursor, that is our cursor that's our real cursor, which I'm moving right here, and then we check, and then we use here a visible boolean function. So actually this determines whether the hardware pointer is visible or not, as I said on the beginning of this code. So actually we are going to see our cursor when our mouse position on the X is less than 0.5 on the negative, and when our mouse position on the X is greater than 0.5, or when our mouse position on the y-axis is less than minus 3.5, or when our mouse button or mouse position on the y-axis is greater than 4.5. So actually in that 4 cases we are going to see our cursor, otherwise our cursor will not be visible. So that was that for this line of code right here. Okay, then last line of code right here, so we are going to delete this boolean expression for our mat clamp, and there we need actually to again use our matf clamp variable, matf clamp function, and in that function we are again going to use our mouse position on the x for the float value, and for the minimum and maximum we are going to use exactly these same values like from our previous script, that is minus 8.5 and 8.5 in the positive. And then for the y-axis we are again going to take our matf clamp variable, because we are going to move our crosshair also on the y-axis. That wasn't the case for our gun. So actually for our gun we take just the current position on the y-axis. We do not touch this y position on the gun movement, because we move our gun just on the x-axis. But in this case crosshair also needs to be moved into the y-axis, and for that I'm going here to copy and paste this. So simply copy this matf function and matf clamp function and copy right here, and then instead here of the x there needs to be y, because now we are in the y-axis in our vector. And then for the minimum y we are going to pass here minus 3.5 instead of 8, and then for the maximum we are going to pass here 4.5 f, and this will be the float minimum and float maximum, so there needs to be f for our float. And guys, that was that for our crosshair movement. So also we are ready to save this and go back to our Unity. And of course one more time go here into the crosshair and then attach our script that we have created right here, so right now. And of course delete this or remove this missing script, because now we have a script for our crosshair. And now we are also ready to test also this behavior out, guys. So I will go here and play our game. So now guys we see our cursor. So our cursor actually, or our crosshair, is right here and we cannot move, or actually when we go behind these curtains we do not see our cursor, and that is the problem in our cursor. So in our crosshair, excuse me. So when we go here into the crosshair graphics we need to pump up this ordering layer to be, for example, 13, because this cursor needs to be in front of all of our here elements, UI elements, and so on and so forth, images and that kind of stuff. So now I will again go back and play our game. So guys, now with our cursor we cannot go more than this, and we cannot go more than this, and also in the y-axis we cannot go more in the air than this, if I can say air like that, and more down than this. So more down than our woods are here, so some kind of woods and our gun and so on and so forth. So that was for our crosshair movement, for our crosshair bounce. So exactly like we did for our gun, we also did for our crosshair, except we add a bounce for our y-axis. So guys, that was that for our movements, and I'm satisfied with this coding right here. So now we need to make a completely different behavior. Now we are going to create an effect for shooting. So we are going here into the scripts, and now we are going to create a new C# script which is going to be gun shooting. So in this script we are going to create that our gun can actually shoot. So open it up in our Visual Studio and we are good to go. So guys, once we are in our script, we will not have in this script any variable, and we will also not have this start method, and we will just have this pure update method. And then we are going to open if statement in this update method and take our input. So I will type here input and then get mouse button down. So this will take a mouse button from our mouse actually. So in this we need to add an integer button that is going to be 0, that actually represents our left mouse button. So actually 0 is left mouse button, and when we pass here a 1, this is right mouse button. So if we touch or if we click our left mouse button, what will happen? So first of all we need to create a vector to mouse position. So like we did in our previous two scripts. So we are simply going to pass here mouse position that's going to be equal to the camera main. So camera and then main and then screen to world point, and then in the parentheses we are going to pass simply input.mouse position, as I said, like we did in our previous two cases. Okay, then we are going to create a collider2D variable. So collider2D, and we are going to simply call this variable col, and then we are going to store that into the physics2D. So physics2D, and then overlap circle. So there will be overlap circle. And then when we open the parentheses, we see that this takes actually the vector 2 point and float radius of that circle. So vector 2 point will actually be our mouse position, and then radius will be 0.01. So 0.01 f for that circle radius will be that. Okay, then we are going to open a new if statement, and in that if statement we are going to check if our collider is not equal to the null. So if we have that collider actually in the scene, and we are going to use a AND operator. So if this is true, and if next statement is true, what we will do? So actually if that next statement is also a collider dot compare tag, so compare tag, this is that function, and we are going to compare the tag with our target tag. So target tag, so actually our targets in the scene will be tagged as this target tag. So what we will do if we have actually a collider in the scene, and if that collider compares with this target tag, if that collider touch this target, so what we will do, we are going to, so what I did here, so I opened the curly brackets here, and yeah, there needs to be one more time a parenthesis, so excuse me, I missed that. So there needs to be, so what will happen if both of this is true? So in that case we are going to simply destroy that game object. So if we hit with our ray, or actually that shoot, if that bullet, some imaginary bullet, kick our target, that is our duck or our targets in general, we are going to simply destroy that game object. So we are going to pass here destroy, and then take our game object. So actually we need to pass here collider.gameObject, so call and then game object. So no, just a game object. In that case that will mean destroy our gun. So when we pass here collider.gameObject, that will destroy actually that game object that we hit with our bullet, some imaginary bullet. Okay, we are going to save this script, but you know already that we cannot test this script as long as we don't have here our targets. As long as we don't have here our ducks and our targets, we cannot test out this script. And for that, now guys, we need to create actually a spawner that will spawn to us from left and from right side, that will spawn to us our targets, our ducks and our targets. And we will do that now. Going back here in our scripts folder, so now we are going to create a new script which is going to be the target. So actually this is pre-last script, then last one will be spawner actually, and we are going to concatenate our target and our spawner script. So open it up in our Visual Studio and you will see in which way we'll do that. And in this script we will have a bunch of variables. So first variable will be sprite renderer. So where is the sprite renderer? There it is. So I made a mistake here, and we need to call this variable simply sprite render. So like this, so we will add this one name to this variable, and then moving on. Second variable will be public animator. So we are going to take the reference from our animator, and this is going to be target hit animator. So actually we are going to call this variable target hit animator like this. And then second variable will be public and then transform, and this is going to be part to rotate. So actually this is going to be the piece of our graphics of our target that needs to rotate whenever we hit or kick that target. So then moving on, we are going to create here a private vector tree. So instead of 1 there needs to be 3, and this is going to be simply a location like this. So then next variable will be public and then float and then stay time. So actually this is going to be our float, first float variable, then private float. So we need to create a new float variable, which is going to be a speed, and we are going to give the default value to this speed variable, which is going to be 2.5f. Okay, then we are going to create a public boolean variable. So actually this variable will detect if we hit. So actually we are going to call this variable is hit. So if we are hit, we are in the true expression. If we not hit, we are in the false. So actually we are going to create here, or actually in our curly brackets, we are going to create get, private and set. So in which way we'll do that? In this way. So actually I will pass here get, and then I will pass a semicolon, then I will pass here a private set like this, and then again semicolon, and you will see later for what we are going to use this variable, but this is not some science here. So this actually we are creating out of this boolean variable getter and setter, and you will see later in which way we will use this. Okay, then end up this with a new curly bracket, and then moving on, we are going to create now three boolean variables. So private bool, and first one, it is going to be is moving in. So is moving in like this, and this is going to be false by default. So actually, because we are going to create here two new boolean variables, we are going to simply copy and paste this, and instead of this name we need to pass here is staying. So is staying like this, and this is also going to be false, and is moving instead of in, there needs to be out. So that's our three private boolean variables. So then moving on, now we need to create a private float variable, which is going to be time left. So time left, this is going to be 0 by default, of course. So yeah, I think I made a mistake here, there needs to be f. So guys, we are going to delete our start method, and we, instead of start method, we are going to create void on enable. So actually void on enable, and in this on enable method we are going to initialize our variables. So first variable is hit, actually this is the boolean variable that we have created, needs to be false. So actually this needs to be initialized as a false, and then we need to pass also is moving in, that needs to be false, and then is moving out also needs to be false, like we had here in the default values. And then is staying also needs to be false. So is staying variable also needs to be false like this. And then we need to actually use our target hit animator dot enable. So actually we need to pass here target hit animator, and that dot enable we need to pass that this is a false actually. So we are going to deactivate that animator when we start our game, and then we need to actually use our part to rotate. That is actually our piece of graphics of our target that needs to be rotated. And then we need to pass here dot rotation, and then dot, so actually there is a equal, excuse me, then equal quaternion dot identity, which simply means we do not want any rotation currently. So actually this part to rotate, and then rotation will be set to 0 for the rotation. So this quaternion dot identity simply means no rotation for that game object. So that means this quaternion dot identity. So guys, then in update method we are going to pass if is staying. So if is staying, if this variable is true, what we're going to do, we need to pass our time left, then minus equals to time dot delta time. So no time left, excuse me, there needs to be time dot delta time, and we are also done with that. So actually if that variable is true, we are going to every frame, or even just in that cases, decrease from our time left this time dot delta time. Okay, then moving on, we are going here in the else statement. So actually now if this variable is false, so what we're going to do if this variable is false, if we are not staying, we are going to take our mathf. So actually there needs to be first of all if statement into this new else statement. So mathf variable and then apps. So actually this returns to us absolute value, and then into the parentheses we are going to pass our transform dot position dot x like this, and yeah, no comma, but there needs to be minus and then location.x. So actually we take a subtraction from these two positions, so location.x, and yeah, we are going to pass here less than 0.01, so 0.01f. And what will happen if this actually condition is true? So now we need to end up this with one more parenthesis, I think right here, or no, we need to delete that parenthesis, we need to open the curly brackets, and we are done with that. So actually what will happen if this is true, we are going to take again our current position of our target, so that is our transform.position, and then equal location, so like this, and then we are going to open a new if statement, and in that if statement we are going to call is moving out. So if that this time variable is true, so what will happen, we need to take our game object, which is our target, and then set active false. So actually we need to deactivate our target, and then we need to pass here a simply return and then semicolon. So then into the else statement after this if met absolutes. So for this if statement we are going to create an else statement. So after two curly brackets we need to create an else statement. Don't miss this, otherwise this will not work, you will mess up everything. So then we need into this else statement to pass again current position of our target, and then this is going to be equal to vector 3 and then dot lerp. And when we point with our mouse on this simply means that linearly interpolates between two vectors. So we need to provide here two vectors and then on the end float t. So two vectors will be, so first one will be current position of our target, that is our transform.position, then second will of course be our location that we have provided into the variables, and then for this float we need to pass here speed, and then we need to multiply that with our time left. Of course there needs to be time.delta time, so time.delta time like this, and this is going to be our last argument right here. Okay, then we need to create a new method right here. So new method will be move out. So we are simply going to call this method move out like this. We are going to open this parentheses, and now in this move out method we are again going to pass our is moving out. So is moving no out, excuse me, there needs to be is moving in, it is going to be false in that case. Then is staying is also going to be false. So where is staying? Yeah, there it is. So this is also going to be false. And then we need to pass now for our location. So we are going to take our location. This is going to be equal to, and in the parentheses we need to again pass our location dot x. So this is going to be onto dot x, and then this is going to be less than 0. So if this is less than 0, and then we are going to pass here question mark new vector. So new vector 3, excuse me, yeah, there needs to be 3, and then into this vector we are going to pass minus 10 for the x and then 0 for the y like this, and then we are going to pass here a 2 dots, and then again new vector 3, so new vector 3, and in the parentheses we are going to pass now 10 in positive and 0 again for the y like this, then end up this with a semicolon, and in the end we are going to pass here is moving out is now true. So instead of false, this is going to be now true because we are in that function, we moving out currently. So what does this line of code means actually here? So location, this is our vector 3 variable, and here we check if our location on the x-axis is less than 0. If this is true, then after this question mark this will be executed. So this next boolean expression will be executed, this new vector 3 minus 10 and then 0 for the y. And if this is false, this location.x is less than 0. If this is false, if our location the x is greater than 0, then this will be executed. So this second argument here in this boolean expression will be executed. So that means if we add here a question mark in the if statement, or actually in the boolean expression, excuse me. So this is for our moving out function. Then we need to create a last function in this method that is going to be public and then void and then hit. So we are simply going to call our method hit, and of course I made a mistake here, there needs to be just a hit. And in this hit method we are going to take our vector 2, excuse me, as an argument. So this is going to be position position vector 2, this is going to be argument of our hit method, and here in this method we are going to open if statement and check if we hit. So if we hit, so this is our variable from our variables, so if we hit we are going to simply pass here return, so return in that case, and then we are going to pass here is hit is now true because we hit on some of our target, and then we are going to call our target hit animator and enable it. So we are simply going to pass here enable is equal to true like this, and then moving out will be true because we are going to move out that target that is hitted. Okay, that is for our hit method. And that is actually everything about our target script. So I think everything here is understandable to you, but as I said, this is not the last script in this video. We also need to create a spawner script that we need to concatenate with this target script in order to that spawner can function and can actually work. So we are going to save this and go back to the Unity editor. And now guys, we are going to create just that last script right here. So we're going to create a new C# script which is going to be spawner and of course open in Visual Studio. But before that opening, we are going here into the hierarchy and we are going to create a new game object which is going to be simply spawner. So we are going to call that game object spawner, we are going to reset the transform, and shortly we are going to attach our spawner script on that spawner game object in order to this spawner script can later on work. So as I said, we are going to open this script in our Visual Studio and we are good to go. So also in this script we will have a bunch of variables. So first variable will be serialized. So first actually 3 variables will be serialized field, and serialized field is nothing but a private variable that will be visible into the inspector panel. So we are going to simply pass here private and then target, that is our target script, and then this is going to be first row duck target prefab. So we are going to call our variable first row duck target prefab, then we are going to copy this variable, and because we are going to pass here are 3 serialized field variables, because of that we paste that variables right here. So second variable will be called second row duck target prefab, excuse me, and then third variable will actually be circle target prefab. So we are going to call this simply circle target prefab, and these are first 3 variables that is marked as a serialized field. And then here instead of private we need to pass here a public for our, so I made a mistake here, there needs to be public instead of private, and also there instead of private there needs to be public in these last 2 variables, and yeah, like this. So then moving on guys, we need to create now private and then q, so we are going to pass here simply q, and then in these angular brackets we are going to pass our target script, and then moving on we are going to pass our variable, so actually a variable name that's going to be first row duck and then target pool. So actually we are going to copy from this because it's very similar name, so instead here of the prefabs there needs to be pool. So actually I'm going to call this pool, so first row duck target pool, and then we are going to pass here a equal and then new q. So where is the q with these angular brackets we need to pass here, because in these angular brackets needs to be our target script that we have created previously. Okay, then we are going to now simply copy and paste this variable because we'll have 2 similar variables like this. Then second variable will be second row duck target pool, so you can imagine that, and then on the end there needs to be simply circle target pool, so like we did here for our serialized field variables, just like we did here, and actually there is a difference that we're creating now a pool instead of the prefab. Okay, then moving on guys, now we need to create last 2 float variables. So first one will be float and then time between waves, so we're going to call this variable time between waves like this, so with the lower cases right here, I made mistakes here, and then this is going to be 1f by default. So then last variable will be private float, excuse me, and then next time, so this is going to be called next time variable, and then for wave. So next time for wave variable, this is going to be 0.5 again by default, and that is that for our variables, guys. So again, we are going to delete our pure start method, and in the update method we are going to open the if statement, and in the if statement we are going to pass here a time, and then time since level is loaded. So time since level is loaded is greater or equal to next time for wave. So next time for wave variable that have a default value that is 0.5. So what will happen if this expression is true? We are going to actually call one method that we need to create later on. That method is our spawn wave. So that's our spawn wave method. We are going to simply comment out this in order to we do not forget this later on. So this is going to be one method that we need to create later on. Then we need to create actually or call our next time, so next time for wave, and we are going to store that into our time since level is loaded. So time since level is loaded, and then we are going to increase or actually add in that variable our time between waves. So time between waves, and that will represent our next time for wave variable. Okay, then moving out of our update method. So now we are going to create this method right here that we have called if this expression is true. So this is our spawn wave method. So we are going to add here a void, and then of course brackets on this method in order to this method can functionate, and then we are going to call or actually create a new variable in this method that's going to be integer. So integer wave count, and this is going to count our waves. So you will see that later, and actually we're going to use here our random range function. So random range like this, that will simply return to us random numbers that we need to specify into the parentheses. So you see float minimum and float maximum. So minimum will be 0 and maximum will be 4 currently. So then guys, we need to create a for loop. So actually we always create a for loops whenever we create some kind of spawners. So also in this case we need to create a for loop. So in this for loop we need to create integer I variable, which is going to be 0 by default, and then we are going to check as long as this I is less than wave count. So wave count variable that we have just created in this method. And then what will happen if this is true? We are going to increase our I variable by 1 simply. So guys, then we are going to create an integer row variable and then store that to the random.range. So random.range, again we are using this random function, and then we are going as a float minimum to pass 3, but this time for the maximum will be 3. Excuse me, for the minimum was 0 and for the maximum 3. I made a mistake in the spelling, and then we are going to add this by 1. So then we are going to call new function here. So that is going to be spawning target. So simply I will pass here spawn target. So there needs to be spawn target. And then we are going to open this parentheses, and again we are going to comment out this code right here because we do not yet create our spawn target method. So actually I made a mistake here, and now we can uncomment this line of code here because we now created that method right here. So then we are going to call that method into the update method. Okay guys, that was that for our spawning wave method. Now we are going out of this, and now we are going to just create this method right here. So we are going to pass here void, then name of that method, and then moving on with our method. Okay, actually there needs to be public. So public and then target. So this is going to return a target variable or function or whatever, because this is going to be the data type of that method. This method then needs to return that, this method needs to return that script. Okay, in this method also we will have one argument. So this is going to be integer argument that will be row. That will simply be row. So guys, before coding anything in this script, we need to create one very short method that is going to be public boolean method, and then this is going to be get is duck right here, right like this. So in this method we'll have a one argument that is going to be integer row, so just like we have in our previous case, and then as I said, it's going to be short script because it's simply going to return a row that is not equal to 2, like this. And then we can proceed now easily with our spawn target method. So in our spawn target we are going to create a boolean variable that's going to be isDuck, simply named, and then we are going to pass here get isDuck, and yeah, in the arguments or in the parentheses we need to provide an integer row that is simply a row from our spawn target method. So then moving on, we are going to create a vector tree location. So we are going to simply call that variable location, and in this we are going to create a new vector tree. So new vector tree, and for the x we are going to pass one more time this parentheses and actually check isDuck. So no is active enable, so simply isDuck boolean variable that we have just created, and then question mark, and you already understand what does this question mark does in the boolean expressions. So then we are going to use our random and then range function, and in this random range we are going as a minimum to pass -7f and as a maximum simply 7f in positive, and this is going to be our two numbers. Then we are going to add 2 dots and then again random range. So actually I will simply copy and then paste this random range function right here, and as a minimum there will be 5 instead of 7, and as a maximum again 5 in the positive. So this is going to be that variables, guys. So now we can move on with that. So for the y-axis it will be 0, and for the z-axis again we will leave this as 0. So this is going to be our vector tree location. Okay, then for the position, so now we need to create a new variable, also vector tree, but this time there needs to be position. So actually we are going to change the name here for our vector and new vector tree. So actually there is no new vector tree, excuse me, so we are going to simply remove this, and actually so remove everything. Actually we need to remove everything here, so we are going to start from the scratch in order to not confuse you. Open the parentheses, call our location variable. So actually if our location on the x-axis is less than 0, what we will do, we are going to add a question mark and then new vector tree, and then in new vector tree we are going to add here -10 and 0 for the y. So then we are going to add one more time these 2 dots and again new vector tree. So new vector tree, but this time there needs to be 10 in positive and of course again 0 on the end. So this is going to be our position. Okay guys, then we need to call our target script. So target script, and this script we will call simply target, like we call that script, and then get from pool. And because we don't have that function yet, we are going to simply pass here get from pool. So like this, manually we are going to pass that method, and in that method we are going to call our row, that's our argument, and we are going to call our position. So our position, and of course on the end we are going to comment out this because we don't have, as I said, this get from pool method right now. So guys, then last line of code here will simply be returning a target variable that we have. So no target with capital T, there needs to be simply target variable. So this is that variable right here, and because of that we comment out this target line of code. We need also to comment out this last piece of code right below. Okay guys, then we need to create this function now. So we are going to simply copy this and then pass right below, so public, and then again target. So this is going to be actually a data type for our new get from pool method, and in this method we will have again integer row argument. So first argument, and then second argument will actually be our vector tree position. So if you remember, when we called this get from pool method, we call also a row and then position. So this is that position vector tree that we are adding right now. So open the parentheses, guys, and then we need to call actually our QE. So we are going to simply pass here QE, and then in this angular brackets we are going to call our target script, and we are going to call that variable simply pool, that is going to be equal to null by default. So simply null right here, semicolon, and moving on. So we are going to open the switch, so switch statement, and we are going to call in our switch statement, or actually set up our switch statement with the row. So row right here, and then we are going to open the parentheses, or actually curly brackets, and in the case 0, so this is going to be first case, that is our that's our case 0, that is our if our pool is equal to first row duck target pool. So first row duck target pool instead of prefab, so don't miss this, otherwise this will not work. And then we are going to break that first case, that 0 case. And then we are going to call, or actually copy this case first and then copy this several times, because I think we will have actually a three cases right here. So I made a mistake. We are going to simply delete these the last three cases and add one more time, because as I said, we will have just the three cases, so I got confused. And in this second case, we are going to again take our pool, but this time there, instead of first, there needs to be a second row duck target pool. And then in third one case, we are going to pass here a circle target pool, so actually circle target pool like these guys, and then break, and we are done with our get from pool method. So then we can now easily uncomment on these two line of codes right here, because now we have that function, we have now that get from pool method. But we're not done in this method. So actually I said that we are done with that method, but we're not done yet, because we didn't return anything. But actually we need to return this target. So then guys, moving on in that method, we are going to check in our if statement if our pool is now equal to the null. So actually, if we don't have our pool in the scene, we are going to simply call our pool and store that pool into the first row target pool. So simply first row duck target pool, and we are done with that. Okay, that was the if statement, and then we need to go outside of that if statement and create a new variable that is going to represent our target. So we're simply going to name that variable target, because this is our target script. And then we are going to again open the if statement and again check if our pool.count, so dot count right here, because our pool is a list. So we are going to check if our count, or actually pool, is equal to the 0. So what will happen if we have 0 elements in our pool list? We are going to take our target script, and then we are going to instantiate a specific game object in the specific position with the specific rotation. So what we want to instantiate right here, we want to instantiate actually a new method, so get prefab method that we have not created yet. So then where we want to instantiate that method, we want to instantiate that onto our position, and then with which rotation we want to instantiate that with no rotation, that's actually quaternion.identity. And for the transform parent, we are simply going to pass here transform, like this guys. And you can imagine we are going to comment out this code, because we don't have yet this get prefab method. So we are going to pass here also a parenthesis that is going to be with a row argument, and then moving on guys. So actually we will bring back this or actually we are going to uncomment this when we create that method. Okay, then guys, we're going to pass here target is out, so target and then is out like this, and we don't have that. And actually guys, we don't have that variable because we don't have in this target script that variable, and definitely we need to go back to this target script, and here in the end of our variables we need to add one new variable. But before that variable we need to import here into the usings. So go here in the usings and type simply Unity engine. So actually no Unity engine, there needs to be simply system. So system like this, we need to use that system in order to we can create that delegate variable. If you want to know more about delegates, simply check out our C# tutorials also here on awesometuts.com, and you will find this better and you will learn more. So we need to add here, as I said, public and then event. So this is going to be event action. So event action, and we will call this variable is out. So simply is out right here. So yeah, I create this in some some crazy ways, so don't judge me about this spelling. I'm every time terrible at this spelling, but anyway, let's save this and go back to the spawner. So now we will have that variable. So again, I will go here and type target, and then is out variable that we have just created, that's our event action. So is out, and then we are going to pass here plus equals to new parentheses. So we are going to add here empty parentheses, and we are going to add here equal, and then this greater sign, and then we are going to open the curly brackets, and then we are going to use our pool variable dot enqueue. So this time there will be enqueue instead, or just a queue. And then in the parentheses we are going to pass our target, that is our game object that needs to be spawned. So then we are going outside of these parentheses, add a semicolon, add one more time semicolon in the end of these curly brackets, and we are done with that. So also we are going to uncomment this right here, because we have there an error right here. So yeah, we'll have there an error because we don't have this get prefab variable, but anyway, we will create that in a second. So guys, that was that for this if statement. Then we need to create here an else statement for this if statement. In the case this is the false, if our pool count is not equal to the 0, we are going to do the next. We are going to pass here our target, and then this is going to be equal to the pool, and then pool dot, and then there will be, instead of the queue, there will be the queue. So actually the queue, and when we point with our mouse right here, this actually, and yeah, I made a mistake here, there is no minus, there needs to be equal. Yeah, I said equal, but I passed the minus. Silly me. Moving on, then we need to pass again our target, and then dot transform dot position. So this is actually our current position of our target, our cute target. This is going to be stored in our new position that we have created. Okay, then we are going to again pass here target, but this time game object dot set active. So setting active, and then there needs to be true in the parentheses in order to we can activate now our target in the case our pool count is not equal to the 0. So we are going to actually pass that our pool is the queue, and then we are going to store this to the new position, and then we are going to actually activate that target. Okay guys, then in the end of this method we are going to simply return our target. So we are going to pass here return target, because the data type of this method is just a target. If you remember, we need to return that target, and now our error is gone. So now we are going to create this method that we called here in the instantiation. So we are going to call here down below, we are going to pass here public and then target one more time. So this the again target method, and then get prefab that we have just called in this instantiating method. So guys, we are going here for the arguments to call our integer and then row. So simple as that. Open the curly brackets, and guys, we need to copy simply this switch statement, because in this get pool or get prefabs, excuse me, we need to have just these switch statements. And instead here of first duck with target prefab, and guys, instead here of first row duck target pool, we need to add here our first row. So first row, but instead of pool there needs to be prefab, and also here second row will again be second row duck target pool. So no pool here, man, there needs to be prefabs, because this is the get prefab, not get pool. So get prefab like this without s on the end, and single, and then on the end there needs to be, and you can imagine, circle target pool. So circle target prefab there needs to be instead of pool, and we are done with that. And also here for the variable, we will not have here any variable that is our pool variable. We will simply return these variables. So we are going to delete that, and simply instead of this pool pass return. And we are also done with this get prefab method. But on the end, outside of this switch statement, we are going to simply return our target. So return, and then first duck target with prefab. So first duck target prefab, and we also return that variable. Now guys, we did everything that we needed to do here in this script, I hope. So we forgot here to uncomment out here the spawn target. This is that spawn target method that we have created, and also here for the row we need to pass a row like we passed previously. And yeah guys, I think we are now done with this script right here, spawn script. So then we need actually to go back to this target, and because of that we now just now created this is out variable. We need also to use this variable in this target script in order to we don't have any problems. So we need to actually use this variable. So let me just find that piece of code right here, and yeah, this is the place where we need to put that variable. So actually we need to call here is out variable action event variable, and then here we need to pass question mark, and then we need to pass a dot invoke, and invoke nothing, or actually invoke that action, so like this, and then we need to pass here a return. So that was line of code that we needed to add here, also like extra line of code in this target method. So actually this is our event, and yeah guys, we need to invoke that event also if this is moving is true, in this if this met absolute variable expression, boolean expression is true. So guys, I will save all of this and go back to our Unity. And before testing guys, we need to import or actually attach here first row duck target, second row duck target, and then circle target prefab. So we need to attach this on these empty slots right here. So we're going to click here on small, or not small circle tag here. So we need to go here into the prefabs, because in our prefabs we have these game objects. So actually we will again go here into the spawner. So first row duck target will be right here. So yeah, and guys, actually we cannot attach this because we didn't attach on these prefabs a script that these prefabs needs to hold. So actually when we go here into the first row duck target, we need to attach on that game object our target script, because this is the target. So when I attach this to this new game object, that's first row duck target, we also need to take our second row duck target and attach the same script, and also for our circle target attach the same script. So don't miss that, otherwise we will not be able to attach these game objects right to our spawner and we'll have a problem. So for these variables, we need to fill up that variable. So sprite renderer will be when we click on this, or actually not click on this is going to be this sprite renderer that these prefabs hold. So but before attaching right here to this directly from our sample scene, we need to go in that prefab. So I will go here in that prefab, and then I will take our sprite renderer. So this is actually the graphics of our circle target. So this is, I think, this target right here, or actually, so click X here, or actually we need to take again our target, click on this small gear sign, right to our sprite renderer, and take this one, first one, actually graphics, that's our target back or target front. I think we need to add here. So yeah, we need to add here a target front, excuse me, instead of target back, so excuse me about that. And also for the animator, we need to drag and drop our one and only animator, circle target animator. Part to rotate will be our whole game object. So we are going to click this small gear sign and click this circle target, because this is the circle target, and attach that right here, and state time needs to be on the 0. So this is going to be for our circle target, and when we go into the first row target, we need to do the exactly same thing. So we need to add here target front for the sprite renderer, and we see that we cannot attach this on this first row target. So we'll click on this small gear sign, so target front, and then for the animator we need to do exactly the same thing like for our circle target, and part to rotate will be itself our game object, and state time needs to remain as a 0. So then for the last one, that is our second row target, we need to do exactly actually we did that because our Unity recognized this, and did that because our prefabs update each other, and Unity already attached this on our second row duck target. So when we go to the first, everything is attached. When we go to the circle, everything is attached also. And now we can easily go back to our scene. So I will save our scene, and then last thing that we need to do here in our scene is definitely attaching this first row target on this slot right here. So now we see that we can attach this first row target, because now this first row target is actually hold our target script. Then we need to go with our second, and then we need to go with our circle right here, attach all of that here. Everything is snapped and attached, guys. Everything will perfectly works, I hope. So for the final testing I will play our game. So guys, we have a gun and we see that we actually spawn our targets and our ducks, but we cannot hit our ducks, and we need to fix this problem. We cannot hit or actually kill our ducks and actually break our targets, and we need definitely to fix that. So I will go back to our Visual Studio, and I think that the problem is somewhere around here. So I will check if we actually tag our, and guys, I spot the problem right here. So the problem is that we want to actually, in the case we made a collision between our hit and between our bullet, some kind of imaginary bullet, and our target, we want to destroy that game object, but actually we want to play animation, moving out animation. So guys, instead here of destroying, we need to paste two line of codes right here. That is our target variable. So target variable from our target class, that's actually stored to the collision.getComponent in parent and in angular brackets target, and then this target hit needs to be hit by mouse position. So that is our two line of codes that we need to pass instead of destroying. And now guys, I hope for now that everything will work. So we'll go back one more time to the Unity editor, and guys, I think that now everything will work. So play this game one more time. So now we will wait for our targets, and when we hit on these targets, again nothing happens, guys. So I don't really know what does this happening right here. So everything works, our spawner works, everything actually currently works except of this hitting on our targets. So what is the problem here? I really don't know, guys. So I need to check this very correctly right here. Actually the problem wasn't in the code. So the problem wasn't in the code. The problem was when we go here into our gun, where we attach our gun shooting script. So we didn't anywhere attach this script, and yeah, this was this terrible mistake. So actually I thought that the problem was into the Visual Studio or the editor or in these prefabs for our targets, but actually the problem was that one basic problem was that we didn't attach this gun shooting script onto our gun, and that was the terrible mistake that I made. So yeah, silly me sometimes. I thought that the problem was some advanced problem, but actually we did the very basic mistake. So very basic problem was here. So we just didn't attach this on our, and yeah, our script cannot work if that script isn't attached somewhere. So yeah, this is one logic and basic thing into the game development of Unity engine. So guys, now we attach definitely this script on our gun, we needed that. And actually when now we play this game, so we will now wait for our targets right here, and when we can now shoot our targets. So we can now shoot our targets, guys. Everything works. Our targets actually flip on the x-axis. And yeah, this is a fact that we wanted to make. So you see that our spawner also works in some awesome way. So he spawned from left side and from right side. This is so cool game. I love to play this game, and I hope you also like this game. I hope you learn something from this game, you learn something new. And guys, that was that for this Shoot the Duck tutorial. I hope you like it, and I will see you in some next tutorial.